Thanks, Nate. Appreciate it. Hi, everyone. See some familiar names out there. Thanks for joining us. My name is Todd Brackett. I'm a solar consultant and system designer for Maine Solar Solutions. Focus of my presentation this afternoon is solar for new construction, but a lot of these concepts will apply to existing homes and commercial properties as well. So let's get into it here. Today's discussion, we'll start off with, how grid-tied solar works and how Maine's net metering policy provides a great value for solar customers. We will discuss system design as well as how building design and the construction process can be optimized for solar installations. Again, like Nate said, we have plenty of time at the end of the presentation to answer any questions that come up. And I'll share phone number, email at the end so that you guys can get in touch with me directly. Maine Solar Solutions, solar for Mainers from Mainers. We've been doing this since 2012. The primary focus of the business since day one has been the design and installation of solar electric systems, right? We recently expanded our offerings to include electrical contracting services. So give us a call if you need homes wired. We provide grid-tied solar electric systems with and without battery backup and off-grid solar as well. We've installed over 3,500 systems in the past 13 years. Maine Solar Solutions has 48 employees, and all of the work that we do is done in-house. We have licensed electricians, trained solar installers, a leads team, right? A sales team. We're taking you through the whole process here. It's exciting to be in the green industry, providing good value and good quality to our customers and providing good jobs and professional opportunities to our employees. How solar works. Really, this is going to be a conversation about net metering. Some of you may be familiar already. This image right here provides a good representation of what a grid-tied solar system is, as well as how Maine's net metering policy works. Grid-tied solar electric is the most common type of solar installed around the state, for that matter, the world. With a grid-tied system, your home is always attached to the grid, and you always have a source of power from CMP. Net metering is a credit-based electricity sharing agreement between the homeowner and the utility. Essentially, we put solar panels on the roof of your home. You're going to make electricity when the sun's out and hitting those panels. That electricity you make will feed active loads in the home first, and excess power produced in real time that you don't use right away will be pushed out the meter and back to the grid in exchange for kilowatt-hour credits. Kilowatt-hour credits will be banked up through the spring and summer months of the year and applied to your bill in the wintertime and at nighttime when you still need electricity in the home, but the sun's not out and hitting those panels, right? That's essentially how solar is billed in Maine and how net metering works. That's an automatic share. There's no delineation of sort of choosing to pull from your panels versus the grid. It all happens automatically, and the organization of credits will be seen on your CMP bill. You'll see how many credits you produced in a certain time period over a month. How long do credits last? Kilowatt-hour credits expire after 12 months. This piece is really important, right? Credits are earned and redeemed on a rolling 12-month period, first in, first out. If you produce more power than you use in any 12-month period, you'll lose any expiring credits. CMP does not pay you for excess credits. So we don't want to size a system to offset more power than what the home uses. Obviously, under the guise of new construction, as it were, for this conversation, we don't know how much you use right away. So that's where my job comes in, to sort of start with conservative targets and build systems for expansion, that sort of thing. A lot of folks are wondering if excess credits can be used to offset another electric bill. The answer is yes. The net metering policy allows you to earn credits on one account and apply those credits to other accounts. This is commonly used by homeowners that have, a second home, a camp, or a ski condo in addition to their primary home. Grid-tied solar FAQ. What happens during a power outage? It's important to note here, grid-tied solar electric systems do not require batteries to operate. Grid-tied systems without batteries are designed to shut down automatically during power outages. This protects the system from delivering power to the grid, where it could endanger line workers trying to get that grid back up and running. A standard grid tie electric system does not provide backup power during an outage. So when the grid goes down, the solar panels go down. In order to utilize those panels at all or provide backup power, a battery would have to be added to the system to provide a place to buffer, store, and discharge electricity to operate loads. We offer a number of different grid-tied systems with battery backup. We can talk about those in a little bit more detail in a moment. A lot of people wonder, why go solar? First and foremost, solar is a financial investment, right? We are offering you the ability to fix the operating cost in a home and protect yourself against rising utility rates. A properly designed system can do that for you. Most electricity consumers consider their electric bill an ongoing, ever increasing operating expense, right? Installing a solar electric system converts that expense into a capital investment that has a fixed cost and clearly defined payback period. Solar electric systems have a measurable ROI, return on investment, a point where the system pays for itself in saving on the electrical bill, right? A bit later in this presentation, I'll illustrate how including solar during construction and financing it through a mortgage actually achieves payback right out of the gate. It's sort of instantly more cost effective to roll that cost of panels into your mortgage than decide you're going to sign up with CMP and pay their rates right out of the gate. Additionally, obviously solar has clear environmental benefits. Solar electric provides carbon-free electricity production, minimizes the environmental impact of producing power. Solar electric is green, clean, and saves money. Building with solar in mind. Designing with solar in mind, many folks ask what the ideal roof pitch is for installing with solar. We're looking at around 35 degrees as being the most ideal and as close to south facing as property. But these aren't overly consequential, right? For instance, right, the loss of moving slightly off of perfect south is the difference of a couple of percentages, right? Moreover, shallow roof pitches on east-west orientations will also perform well. I think the bigger issue here is shading, right? Shading is the greatest negative impact on solar production. So we want to consider what trees are affecting shade on the property. That's something to think about when you're doing your site plans, things like that. A good rule of thumb is to maintain at least 50 feet of tree clearance in an arc southeast to southwest of the home. During the solar array design process, we factor in the impact of adjacent building components as well, such as dormers and chimneys that can throw hard shade lines on otherwise productive solar roofs. Right, I think the main piece here is shading. Anything that's sort of east, down south, and west is going to have the potential to be a really good solar roof. Shading is your biggest factor here. Roof mounting. Solar arrays can be installed on just about any type of roof surface. Most common on pitched roofs is asphalt shingles and standing seam metal. But we can also install on flat rubber roofs, more applicable in commercial scenarios. Asphalt shingle roofs use a flash detachment point that you see here. Right, this piece of metal flashing acts sort of as a shingle itself, right? An L foot sits right on top of that piece of flashing, separated by a rubber bushing and creating a watertight seal. Then this lag goes directly into your rafters. We've been using that attachment point on shingle roofs for 14 years of business, 13 years of business, and no problems with roof leaks yet, which is great. Certainly no problems with roof leaks on a standing seam type. We use clamped attachment points that clamp right onto those raised seams. So For those of you worried about perforations in the roof, standing seam is a good way to consider going. And then flat rubber roofs as well. We use a ballasted or weighted non-penetrating racking system. We can provide some information on how systems weight can impact roofs framing specifications if it comes to that. Planning with solar in mind. This is a big one for any of you builders out there. If you are a building professional, you know the number one complaint of plumbers, electricians, and HVAC contractors is limited space for mechanical systems, right? Grid-tied solar electric infrastructure like inverter systems, small stuff don't require a ton of space in mechanical rooms, but batteries do, right? In Maine, batteries should be installed in a conditioned interior location in a mechanical room and close to the electric panel it will be installed to support. Battery systems include automatic transfer switches and sometimes require that the installation non-critical load panels. In addition, battery systems are typically located between the meter and the main service panel, so planning ahead with electrical contractor, right? That'll be something that I can sort of coordinate with your electrical contractor about. Additionally, we need to consider DC wire runs that need to make it off of rooftop solar panels. Those DC wire runs need to land by the inverter in the mechanical room. So we can coordinate with that. New construction gives us a good opportunity to get into those walls before insulation is up, that sort of thing. So we can coordinate on that, stub wires through the roof in the case of asphalt shingles, and keep everything nice and clean from an exterior aesthetic consideration there. Maine Solar Solutions and our electrical contracting arm, MSS Electric, can help streamline the organization of electrical components with space for everyone in mind. Right, we're going to sort of hold your hand through it all. We'll take care of everything with you. We prepare and submit permits, right? We have dedicated consultants, primarily me, who will coordinate with builders about all aspects of these projects. We can also step in to be, you know, a beacon of information for homeowners who have solar specific questions, that sort of thing. Solar as part of an integrated home electrical system, right? Just a shameless little plug here for MSS Electric. Solar electric installers are specialized electrical contractors, right? Maine Solar has been installing car chargers, managed load panels, and performing service and panel upgrades as part of our solar installations for years, right? For the past year, we've offered full service electrical contracting services through MSS Electric. We are leveraging the workforce and organizational systems we've built and become proficient at building over time as sort of a way to bring cost-effective and innovative solutions to builders and homeowners alike. So if you have electrical contracting needs, house wiring, whatever it is, give us a call. How we design solar systems. This is where my day-to-day job comes in a little bit more here. Essentially, we start here. Let me get to my right page here. Essentially, we design a solar electric system to offset a home's annual electricity consumption. Right? With an existing home, we simply review a recent electricity bill to see what past few years kilowatt hour consumption looks like. With a new home, we apply our knowledge of designing systems for new high efficiency homes, and we can take a look at how electrified the home will be to make a good consumption estimate. With many new homes featuring all electric heating and heat pump hot water heaters, we typically recommend a system that produces around 10,000 kilowatt hours a year. Transparently, that's based on, you know, not a lot. But people's in-home usage is going to be pretty subjective, but 10,000 kilowatt hours is a good place to start, and we can always build systems to accommodate future expansion. Obviously, if we're talking about 2 electric vehicles and a hot tub and a sauna, we might start a little bit higher than 10,000 kilowatt hours a year, but that's on a case-by-case basis. I would like to take a moment here to discuss the difference between system size and system production, watts versus watt hours. Solar electric system size is measured in how many watts of solar are installed on the array. We simply multiply the wattage of the panel by the number of panels. So for instance, an array consisting of 10 500-watt panels would be 5,000 watts, or a 5 kW system. We then use industry standard modeling software to determine how much electricity, how many kilowatt hours those watts will produce in a year. The model takes into account geographic location of the system. We're obviously in Maine here and not Arizona. We just take into account the angle of the array, its azimuth or orientation towards south. Weather data is factored in, using decades worth of data to determine the impact of cloudiness and temperature on system performance. So it's all very measured, right? And I will say that we try pretty hard here to give conservative estimates about what we think the system will produce in a year. And that is the response we get back from most of our customers who've been up and running for a couple of years, come back and say, you know, we're overproducing by a margin of 2 to 5% or something like that. We'd rather be on that side of the conversation rather than overproducing and coming back around that way. Just as a reminder, right, the same size system, same 5 kW system will produce different amount of electricity under different circumstances based on roof pitch, orientation, and most importantly, shading. That's an important piece to remember as you compare quotes from different installers. Different people will model system production in different ways. So keep that in mind. We'll get into how we do ours in a moment here. Solar array layout and specification. During the design phase, our solar consultants, will size and design a solar array to optimize performance, choosing roof planes that are oriented as close to south as possible. We also take into account local jurisdictions, code requirements for roof access. Some of you might be familiar with this in some cases. Some towns adhere to the National Fire Code roof setbacks to be able to access the ridge cap in the case of a fire. That's all stuff that we're aware of and falling in line, obviously, to sort of design in the proper way, so we won't run into any hiccups during the permitting process. We also adhere to aesthetic appearance of the solar array where applicable with the homeowner. You see some pretty funky layouts in some cases where we don't have a ton of contiguous roof space. Anyways, right, we sort of present or design a couple different systems, and then we coordinate with the homeowner and or the builder to satisfy the specific needs of that person. Designing for new construction in particular is always fun. I get to dive into building plans like this one here. So initially in the beginning phase, you have a customer who's interested in solar as well. We can work off of your plan set to design and specify the solar electric system, right? From these plans, we can pull and model important information about the roof, like roof surface area, roof pitch, and roof direction. A site plan is very helpful in combination with these building plans, so we can determine the orientation of the building towards south. But I can use these plans to develop a SketchUp model. This isn't the prettiest model in the world, but it gets the job done as far as space is concerned. The biggest piece missing from most house plans is a comprehensive idea about existing shading on the roof. We can make assumptions about shading with satellite imagery from Google Maps, but shading will be measured to a to a much more certain degree once a structure is erected, and we can fly a drone and get an idea about existing shade on the property. So drone imaging and site analysis. This is something we started doing within the last 2 years or so. We fly a drone at a property to be able to build you a 3D model of the house. Right? The drone is able to capture precise roof measurements, shade readings, the high-res photos we collect during the drone flight are imported into our modeling software. We use a process called photogrammetry to put 300 some odd images together and build you a 3D model of the home. We use this to model panel placement options and allow for maximum system efficiency and performance. This tool can be used during consultation to visually show how systems performance is impacted by sun angle and shade throughout the year. It's also a great tool to allow visualization of the solar array and appearance of different panels on the roof. I want to take a moment to show you guys how comprehensive this program is. So I'm going to pull this up here. Give that a second to port over. Right here, we are looking at a model home that we installed solar on for Zero Energy Homes, who might be in the room right now. I'm not sure. But this is a look at the drone model, right? Again, we have 300 some odd photos of the roof of the house from different angles that are put together to make this manipulatable model. We can see shade data at different times during the year. We're going to angle this perfectly north to south here. And we can look at December, right, last day of the year, sun's really low in the sky. We can see shade data from right in the middle of winter here. Obviously watching the sun sort of come across. We're not getting a lot of solar exposure in those winter months. But if we toggle this slider back to middle of June, we can see how much more hours of sunlight the roof is receiving over time. So really comprehensive program, right? We can see roof perforations in the case that there were any on this particular roof. We could go ahead and say, well, there's a stink pipe right here or a vent pipe right there. We got to lose a panel. So it's a really comprehensive program. We get a really good idea about curb appeal, right? Aesthetic concerns that a homeowner might have, that sort of thing. So that's a little bit about our drone program. Pretty cool stuff there. Back to this presentation. Once we have time to sort of model everything, we will dive into the offerings that we have, product types, starting with solar panels. Generally, we work with different solar panel types, large format commercial panels and smaller residential style panels. We're one of the only installers consistently working with larger format commercial panels up here. We've been doing so for over a decade. These are large, cumbersome panels. They're hard to work with, but we've been doing it for a while, so we will continue to do it. With larger format, higher wattage panels, we can offset more power or the same amount of power using fewer panels overall, and keeping costs down that way. Then we start to weigh visual and aesthetic concerns of the individual homeowner. Smaller black framed panels blend in better with darker roof lines and generally provide for a cleaner overall curb appeal in the eyes of some homeowners. Finally, these panels are both guaranteed to be producing at least 87.4% of their original production at the end of the 30-year warranty life. That's incredible, right? And these warranty lines are likely conservative. So you're looking at a panel that's going to have value well beyond 30 years for whoever is in the home at that time. So thinking about homes being passed on and retaining value because of the solar system, passed on to next of kin or sold to another homeowner, all that sort of stuff. We will talk about inverter options for installs without battery backup or that want to add batteries later. We recommend the Solar Edge inverter system. This Solar Edge system is the best inverter that we have to pair with those large format panels I was talking about on the previous screen. Solar Edge pairs a centralized inverter, string inverter, with an optimizer installed with each panel. Optimizers allow for mitigation of production loss in the system due to shading or due to a failed panel. Those optimizers will communicate with each other and say, you know, we got a problem panel over here. Let's decrease voltage over there, increase voltage on panels in fuller sunlight so that the system as a whole can make the most amount of power possible. Those optimizers will also track individual panel production, and panel level data will be recorded on a monitoring app that the homeowner has access to check on their system. So centralized inverter is hooked up to the internet. Optimizers per panel will track individual panel production. That data will be logged on a Solar Edge portal for them to look at. For folks looking for a battery backup system, their choice of battery can impact the inverter option. In some cases, Solar Edge has a battery system, the Tesla Powerwall 3, for example, which is a battery, features an integrated Tesla inverter. And then we also sell Franklin batteries, which give you the option to use either their inverter or a third-party inverter. So something to keep in mind during that process. Deciding to go with a battery may change the inverter infrastructure. Battery backup, right? Near instantaneous backup power during grid outages, right? This is for the people that want to be able to store some localized solar made electricity on site in the case that the grid goes down, right? This is a good alternative to gas generators. And in general, these batteries are good at powering critical loads in the home for a day and a half, 2 days, maybe 2.5 days on one of these batteries, right? Franklin and Tesla listed out down low here have about 13.5 kilowatt hours of storage. When we presume that, right, when we try to think about how much that really is in practice, you're really looking at, you know, critical loads being a well pump, a fridge, freezer, some outlets around the house. These batteries are all stackable. So one isn't going to do a great job to take care of heat pumps necessarily, or heat pump hot water heaters, but as you stack additional batteries onto the one, you can get more comprehensive whole home backups. We have ongoing support and warranty coverage as well. This is something that I want to highlight that's unique about Maine Solar Solutions. We have a 30-year parts and replacement labor warranty. This covers the inverter systems and the solar panels. Right. This is Maine's longest warranty, right? And I think the big piece here is that replacement labor. These parts are warranted for a long time already from the manufacturer. Maine Solar Solutions warranty covers replacement labor as well, which in every other warranty conversation is not going to be taken care of. So, you know, I like to digress here for a minute and just say, solar technology is all really good for the most part. I mean, you can find panels that are lower wattage and not worth installing, but I think you'd have a hard time finding a solar installation company in Maine that's selling a product that's not worth installing. And so I think we sort of digress back to, okay, the conversation then becomes not what's the best panel, but who's the best company to get into business with for 30 plus years. And so we are offering that warranty as a token to say we plan on being around for a long time, and we have been around for a long time to this point. 5-year workmanship warranty is pretty standard. That covers our installation and labor, the electrical work that we do, roof work that we do. All of this stuff is transferable if the home is sold or passed on to next of kin. So that's a little bit about warranty coverage. Next, I just want to get into a quick conversation about value in these systems, right? So right here, we'll take a look at a pricing example for 2 different solar panel types, right? This is sort of our base rate new construction pricing example. We have an SEG 595 large format panel with a silver frame and a smaller black framed Hyundai 435 watt panel. The conditions that these panels were put under to make an output number here are as follows. We're looking at an azimuth 155 degrees towards the southeast, a roof pitch of 35 degrees, and annual shading of 15%. So this is not a perfectly ideal situation, but rather a decent setup that represents solid sun exposure, but not the best ever, right? In this pricing table, you can see that the SEG 595, both of these are sized to offset 10,000 kilowatt hours a year, or as close to it as we can get. Their modeled output is right here. We can build a larger system in this using this SEG 595 panel with fewer overall panels, and it's in that lower panel count that's going to explain the difference in price on the bottom line there. So if value is what you're after, you're going to feel myself and other solar consultants with Maine Solar lean towards the value in that large format panel. Right. I want to talk about return on investment, right? This is a project savings and payback calculation for that 16 panel SEG 595 watt system here, right? So again, we are talking about a system that makes about 10,000 kilowatt hours a year, which from CMP costs about $2,500 a year, right? That cumulative annual savings is going to pay back the initial cost of $25,000 in about 8 years, right? In this calculation, we are presuming a couple of things, of course. CMP has planned a 5-year rate increase that amounts to about 30% in an increase over the next 5 years. You should have all, if you pay CMP bills, gotten an email about this. 30% is huge, and that's factored into the calculation here. Additionally, we're presuming a 3% annual increase in electric rate for the remainder of that 30-year warranted period. 3% follows averages nationally since 1960, and average CMP rate increase since 2014 is also 3%. So again, not a completely ideal system with full sun, but sort of a more average system, an 8-year payback. The numbers look really good. The other value proposition I want to walk you through is, right, this is a lifetime of electricity paid via mortgage. And what I've done in this calculation here is sort of outline the cost of what this electricity would be if it was lumped into your mortgage. This is the value here, right? Owning the means of production for your electricity allows you to fix the cost of that electricity in the face of ever increasing utility rates, right? Using the example solar system from the previous slides, we can plug in the project cost here, $25,428, into a mortgage calculator. We're looking at a 30-year loan term and an interest rate of 7%, the cost of that solar system that makes about 10,000 kilowatt hours a year is $169 using this mortgage calculator, right? So $169 in a mortgage versus that same electricity from CMP monthly would cost about $206. We have a cost of electricity over year 1, year 10, year 20, and year 30 in this chart down here. So my point here is that the mortgage payment, lumping in a solar system into your mortgage right out of the gate in year 1, saves you about $400. By year 30, the savings, right? You're talking about a fixed rate for that electricity lumped into your mortgage. The savings between that and what you would otherwise spend buying that same electricity from CMP is astronomical. So, hop on further. We have frequently asked questions. Just to sort of rattle a couple of these off, and then we'll get to some questions after this. Snow on the panels is not a problem. It will consolidate, slide off of glassed up panels pretty easily. In fact, I'd be more worried about what lives underneath the panels in the case that you have a deck or something beneath that with outdoor furniture or a hot tub or anything like that. Replacing the roof is always a question that comes up. This is, applies to shingle roofs in particular. Shingle roofs will break down over time due to exposure from sunlight. And when we put solar panels over asphalt shingle roofs, we take away sunlight from the equation. So you should expect that these solar panels are going to act as an insurance policy for that roof, right? Essentially, you shouldn't need to get underneath those panels and replace shingles underneath for as long as the solar panels are up there. Edge shingles that are still exposed to the sun will need to be replaced in due time, but that can be done without taking panels off the roof. These are essentially no maintenance systems. So there's very little that can go wrong. They're fixed to the roof. They sit there. They make power for a long time. There's not a lot of regular maintenance. Yes, you can use kilowatt hour credits to offset multiple CMP bills. I think I mentioned that a little bit earlier. Solar increases home value. It's hard to put a thumb on that exactly, but and it depends on the market that you're in. But certainly, as a society, we move towards a more electrified society. I have a hard time seeing how a house being sold with electricity included is not a selling point. Tree branches falling on the system is that type of damage. That's always a good question as well. That type of damage is not covered anywhere by Maine Solar Solutions or by other installation companies for that matter. That's going to be covered by homeowners insurance, and so it goes to say that a solar system should be included in the value of what's covered by homeowners insurance when you set up that agreement. So that gets through most of the information that I wanted to get through today. Nate, I'm going to go ahead and turn it over to you if you have had any questions come in, or if anybody wants to chime in. I'm not sure how you want to run that. Go ahead, Nate.
Yeah, so there's no questions so far in the chat, but we can certainly stay on for a couple more minutes, of course, to give anybody an opportunity to type that out. Of course, Todd, if you want to switch to the next slide with your info, folks, feel free to take that down if you think of a question later that you want to ask Todd. Of course, reach out to our info line at Maine Solar Solutions and check out our website, which has a page dedicated to new construction, but also all things solar that we do here at Maine Solar. Todd, that was a great presentation. Thank you for your time. I figure we can just sort of sit here for a couple minutes if anybody has any further questions. Yeah. If not,
sure.
feel free to exit the presentation. But yeah, in the meantime, we'll happily wait.
Yeah, if anybody has anything they want to chime in, feel free.
I will just make a note that if anybody, oh, here we got a question came in.
Is there a difference between installation on an asphalt roof versus a standing seam metal roof? In cost, not that's that measurable, and maybe a difference of a couple $100 based on attachment points, but not something that would affect payback, for example, or some drastic increase there.
I will mention.
Thanks, Peggy.
If we also had a presentation yesterday for off-grid, so if anybody's interested in off-grid solar, we also recorded that presentation, and that will be able to be found on the website. Similar to this, if you ended up joining late and missed the beginning, we did record this, and we will be sharing it on our website as well. So in case you missed the first couple slides, you'll be able to rewatch that.
Who else we got in here? I see Jared Damon. I recognize that name. How you doing, Jared? Not sure if you're still tuned in, but if you are, hello. Cool.
Excellent.
Thanks, Nate.
Yep. Thank you, everybody. Todd, thank you for that great presentation. Everybody, thank you for your time today and for joining us. Of course, like I said, feel free to reach out to our info line or to Todd directly for any future questions. And, thank you again to Passive House Maine for holding this great series of events. I encourage everybody to check out their website and see the other great events and presentations that are going on this week. So with that, I'd like to say have a great day, everybody, and thank you again for joining us.
Thanks, everyone. See ya.